Good morning, ladies and gentlemen, distinguished panelists. Welcome to the special event, Cryosphere, Impact of Retreating Glaciers. I'm Yulia Vistovna, Senior Water Program Officer, and today we will discuss how glaciers impact us, our culture, our environment, why it is important to consider it, how it's integrated in UN agency agenda, and what we can do. Please let me to start to introduce our panelists. So today with us we have Johannes Kuhlmann. He is UN Water Vice Chair. We will have Yolanda Lopez, who is indigenous Maya community woman, but also hydrologist and hydrogeologist. We have Adrian Lema, Director of National Center for Climate Research. And we have Irina Gorodetskaya. She is lead on IPCC report on physical science, but also senior researcher in Center of Marine Environment Research and at the University of Porto with huge experience on Antarctica. So also we have our special guest Martin Krause, who will give a closing remark to the event. So please let me to start from Johannes. Johannes, you have very experienced UN leader. Please, can you tell us how glacier agenda is covered in UN agenda and why it is important to consider?
Good. Yeah, thanks. Thanks for inviting me, Julia. I'm happy to be here and discuss a topic that is coming up more and more and more. So, if we think, my home organization is the WMO, World Meteorological Organization, and I started as the Water and Climate Director. But then, after the years, I've become the Water and Cryosphere Coordinator. So, because in climate adaptation first, there was this big discussion around the cryosphere, and so I think within this whole discussion that came through a more Earth system view on things, and not only weather or not only water or climate, we have realized that the cryosphere is such an important factor. And for cryosphere scientists, this had always been clear, but for UN system policy making, this hasn't been so clear. So yes, our water is stored in the cryosphere changes so fast. And then, of course, the first natural thing is that people think about, okay, what's the change in water availability? And there's huge impacts on the Indus River. We have almost 50% of the water that comes from the cryosphere. I have been part of a study in my home country, Germany, where I worked some time before. And in our case, the 7-day low flow in our biggest rivers is more than 30% from snow and ice melt, and that impacts the cooling water availability for our power plants, the transport capacity of bulk goods that we need for our industry. So the impacts are so manifold in terms of how cryosphere relates to really the different dimensions of sustainable development, and that's economics, but it's of course also environment, and it's also society, because it impacts people, and it of course has a is that your microphone? No, okay. So yeah, there we go. Cryosphere is such an important part. It has been neglected in the past, I think, and in this discussion around where are now the chances for us to change the course of how we perceive, plan, and implement sustainable development. I think cryosphere has an important role because we tend to think about the negative consequences of glacier melt and sea level rise, but we also need to think where are the positive lessons that we can draw and implement on this fact that's happening. We cannot change the glacier melt, but we can think about how can we invent green and gray solutions that let us take over some of the functions or so that we have had the service that we have received from the cryosphere. And in that regard, I think the positive externalities is the key word, because Nobody will invest in preventing glaciers. That's not a business case, that doesn't work. But if we think what are the, in relation to other economic, social and environmental trade-offs, what can we gain from the cryosphere and how can we use that change that is negative and dramatic in a way that we plan resilient systems for the future. I think that is the key. And that has to do, of course, with food, with energy and water availability, but also with disaster risk reduction and so forth. So that was a bit the general intro and philosophy, and how does that relate to the UN? I think in the UN Water we have, after the big water conference in New York, very well realized that we need to transform the global acceleration framework that we had for water to a broader scope, to mainstreamness in water and climate and cryosphere. And to that end, we are now developing in the UN system a common UN strategy and implementation plan on water, so that not all the different parts of our system do something related only to food and FAO and only to data in the organization that I come from and only to the good and super important isotope hydrology that you are doing, but we need to bring that stuff together and we need to develop a common log frame and implementation plan, because else we always have to invest more and more and more. And the real issue is, how do we understand how we can invest differently, how we can perceive water differently in an economic way, and how we can then find a solution that's also good for the people and the environment. So we have this strategy development now. The first draft will be discussed on the 15th of December now, so we are really in the final stages of trying to organize the first draft of this strategy, and it will certainly also try to address these cryosphere issues. And then maybe the last thing, because our friends from Tajikistan were with the Netherlands co-organizing the water conference, one of the outcomes is also that we will have in 2025 a special year that is dedicated in the UN on the topic of glaciers. So that's also an important step that we will have on the way to the 2030 deadline. And in 2030 we will have to have an alternative systems thinking, I think, one that transforms our extractive systems to circular systems, our trying to have big monocultural solutions for problems in agriculture or energy to a more diversified system. So I think there are a couple of key guidance principles for us, which are diversification, which are circularity, which are inclusion, which are a different way of economic thinking. And I think that's enough for me for a start, for introduction. If you don't stop me, I'll talk for another 15 minutes. And my luggage is still in Zurich, and probably my brain is also still in Zurich. So thank you for the time, and thank you for the invitation.
Thank you for excellent overview and to show us how multidimensional this problem and how UN agency support in different ways. And also you mentioned very important point like science. And here I would like to ask Adrian. Adrian, from the scientific perspective and beyond, how can we better understand glacier melt, but also cryosphere collapse on our ecosystems? What is the scientific tools? What can best to measure it?
Thank you so much, and thank you very much for inviting. That's a very big question, and I'll try to give a few pointers. But first, I think since we are in this setting, I'd like to start out with a small anecdote. So in the 50s, we had a very famous Danish climatologist, Willy Dansgaard, who were on the Greenland ice sheet, looking up at the clouds and really wanted to measure what are the temperature of clouds. And that's pretty difficult. But he discovered that maybe he could use isotope research to do that. So he actually pioneered that research, and later evolved into ice cores to determine what are the past climate changes that have happened. So I think in this setting it would be suitable just to give a warm thought to Willy Dansgaard back then. But also, of course, climate is changing now, and especially it's impacting the cryosphere. So we know that, for instance, in the Arctic region, we have a amplification of global warming. So the global warming is about 4 times higher than the global average is. So it's really changing fast relative to global warming in general. And those changes are really having a huge impact. So we're trying to understand, especially, how can we assess those changes in the best possible ways. And I think when it comes to glaciers and the cryosphere in general, we do know that the glaciers are retreating, they are melting, and they are retreating at a faster pace than usual. So, for instance, in Greenland, which is and in the Arctic, which is a special interest, of course, to us in Denmark, the mass loss of the Greenland ice sheet has been retreating or decreasing for 27 years in a row now. So it's really picking up pace, unfortunately. And we, of course, as a low-lying country in Denmark, we are, of course, very interested in how does that change the sea level, because the sea level is rising. It's rising quite fast. We do know especially from satellite data, that the pace of increase is about or more than double now as it was compared to the 1990s. So just within a few decades, the sea level has been rising more than double than it was on an annual basis a few decades ago. We are really engaged in how can we assess these changes, and we look into, of course, different types of observations, both on the ground and from satellite, and then incorporating those data in high resolution models, which is really the key task here. I think I will come back to that maybe later if time allows, but that's really a core task. But what we also would like to do, and do even more, is assessing what are the impacts of the changes that we experience. So some of the changes we know very well, and I think someone in the panel is maybe more knowledgeable than I am on that, but especially in terms of water resources and scarcity of water resources, it can have a huge impact around the globe where we have mountain glaciers especially, but also in some parts of Greenland actually. Also, I think the increase of natural hazards is something we need to be aware of. So when glaciers melt, they do increase the risk of landslides, for instance, and avalanches, and it changes both the communities and the ecosystems in fundamental ways. I would also like to mention that when it comes to Greenland, for instance, there are both positive and negative impacts of glacier retreats. And I'm not the one to determine what the balance are, but I think I would be inclined to say that maybe the negative impacts are larger. But there are both positive and negative. So for instance, in Greenland, they're looking into, and we're helping to look into the future runoff from the ice sheet and glaciers in terms of rivers. So how can they utilize that in terms of hydroelectricity, which is of course one source. Another source of possible positive impacts would be when the freshwater reaches the fjords. It causes a stir up of nutrients and planktons, which are useful for fish, and then of course for fishery after that. So the marine productivity may actually benefit, at least in some cases, to this melt. But then again, the negative impacts are also there, also in Greenland. So on top of those that I've already mentioned, I think especially when you are dependent on traveling on the ice, on your dog sled or on your snowmobile, whenever that becomes more unstable, that's a huge risk for you as a hunter-gatherer and for the local communities. And that's really something that we're looking into. We're both looking into how that instability is appearing, but also how can we help them using satellite data and machine learning and artificial intelligence to see where they can be and where they can't be. So these are some of the impacts that are also there in Greenland, for instance. And I think I'll stop here, but thank you very much.
Thank you very much. It's like a diversity of scientific tool what you open for us, and also clearly show impact positive and negative on the example of Greenland. And I would like now to continue a little bit scientific discussion, but also thanks to about the mentioning of isotope hydrology, what we are working on to precise also climate models. And we continue this subject. I would like to turn to Irina, who will tell us maybe more about Antarctica, because for me, Antarctica is far. And I know I'm worried about what is melting, but I still don't understand how it's impact me, how it's impact people who is far from Antarctica. So Irina is a scientist with very advanced experience on Antarctica. The largest amount of glacier in the world, actually we know what exists, and what we expect in the future. And how can we use isotope hydrology? Because I know you told me this secret, what you're now using isotope hydrology. How we can use isotope hydrology to better understand those extreme events what affect in Antarctica.
Thank you, Julia, and so thank you for coming to our session. And I will be talking on behalf of the Antarctic community. I'm an atmospheric scientist, researcher working in Antarctica and doing measurements in Antarctica. So I'm going to Antarctic Peninsula every year. And what we see is that there is really a lot of melt now happening in the entire Antarctica, mostly from West Antarctica and the Antarctic Peninsula, but also starting part of the East Antarctica melting. And exactly, yes, Julia has mentioned this is far remote, and we wonder like why does it affect us and how does it affect us? But actually we have now, so the melting from mountain glaciers, from ice sheets, both Greenland and Antarctica, are already now contributing, they are major contributors to the global sea level rise, along with the thermal expansion of the ocean. And actually, if we take the entire increase of the global sea level rise, a lot from the ice sheets, it has been increasing about 4 millimeters per year globally. So I mean, I think this is really a small number. I mean, I can compare it to, well, my pinky fingernail, so this is like less than 4 millimeters. But actually, this is averaged global sea level rise. So we are talking about the entire surface of the global ocean. So if we translate it to the amount of water that is being added to the ocean, so we're talking about trillions of cubic meters of water, which is a huge amount. And when we talk about regional effects, so we have actually, there is this gravitational pull. So the mass loss from Antarctica, it affects directly not the Southern Ocean, but actually there is the decrease in sea level rise just in the nearby Antarctica. But by this gravitational pull, so the water redistributes quite fast, a matter of several days around the globe. And the direct impact is actually on the most distant regions, so the equatorial regions where we have the low-lying islands and northern hemisphere land, so the coastal regions in the northern hemisphere. So this is really alarming now, the changes that we see now. And the problem is that this has been accelerating. So until Antarctica has been more or less stable until, well, the 2000s, like in the last two decades, actually, there has been strong acceleration of the melt from Antarctica. And it's been accelerating, and this acceleration is actually continuing every year. And if we continue at the same pace of the global warming and the impact on Antarctica and Greenland and the mountain glaciers, the projections show that we may have up to 1 meter or even higher of sea level rise by the end of the 21st century. And I'm saying higher because Antarctica is actually behaving may behave, and it's already starting to behave in an unstable manner. So now, compared to Greenland and mountain glaciers, the contribution to sea level rise from Antarctica is slightly less. But in the future, already in the next 5-10 years, and especially in the next 50 years, this contribution from Antarctica can be much larger, and is projected to be much larger. And these uncertainties, actually, they call them instabilities. So they are really high risk instabilities that may cause even 3 meters of sea level rise by the end of the century. And by 2300, it can be 12 up to 20 meters of sea level rise. So we're talking about huge numbers here, right? And about the future changes of Antarctica. And about your question of the isotope hydrology, so this is one of the tools we are using in Antarctica. So we are using stable water isotopes, and we take samples of precipitation in Antarctica. And in particular, in my research, I study extreme weather events in Antarctica. And they're really important around the globe, and especially in Antarctica. And we can use the stable water isotopes to understand not only the temperature locally, because they're our proxy, they're our local thermometer, as was discovered by Danskart, but we can also understand the sources of moisture, where it comes from, and its pathways. And what we have seen, we have a paper just published actually yesterday, that the extreme events in the February 2022 in last year, which was the record high melt on the Antarctic Peninsula, it was actually caused by the water evaporated of the subtropical Pacific. So there is a link, we call them teleconnections. So there is a link what happened in Antarctica to the subtropical Pacific with the moisture sources. And we also link this to the tropical convection. So there is all this interlink between the climate change in the lower latitudes and Antarctica. And then Antarctica responded to this change by a lot of melt and adding actually a lot of instability, risk of increasing instability to the ice shelves. And the ice shelves in Antarctica, they have this buttressing effect. So they actually hold the glaciers in Antarctica, and they don't let them to accelerate and to go into the ocean and to melt. So when we lose the ice shelves, actually we lose this buttressing effect, we lose this support. And once we lose the ice shelves, which are already floating, so they don't contribute directly to the sea level rise, but once we have them disintegrating, the glaciers that have been supported by these ice shelves start accelerating. So this is, again, a very remote region, and when we speak about the future changes, we have to be really aware of this long-term changes that, especially Antarctica, as a slow response and now accelerating response can bring us. We see these changes now, and the changes in the near-term future, and especially in the long-term future, speaking about the generations ahead, about our children, the children of our children, this is a high-risk danger from Antarctica, which is reacting to the global warming. So.
Thank you very much. So now we can see what even it's remote, it still impacts us, and it's us actually like daily. And also we mentioned about extreme events and isotope hydrology, and here with us we have Svetlana Krakovska from the Vernadsky station. We have the longest records of isotopes in precipitation in Vernadsky station in Antarctica without any interruption for 60 years. So thank you for that. So now we can precise and to use it in different models. And thank you for mentioning also about these diverse tools. And we heard about science, but what about the local community, local people? So let me to ask the next question to Yolanda. Yolanda, as a representative of Maya community, but also of hydrologists with a long experience in Cryosphere study, because you had your research in Canada also. And what role can indigenous people and local people play in the better understanding of the role of glacier melt and cryosphere, and how we can collect this local information to global scale?
Well, thank you very much for the invitation, and to the panelists, thank you also very much. I want to please start with a clarification. When I'm talking about indigenous knowledge, it's not separated to the Western science. So we also, indigenous peoples, we have our own science. And it's important for me to clarify this at the very beginning, because it's politically and ethically correct to include different knowledge systems for understanding Earth processes. Because this world is so complex that we really need to bring into the table and into the decision-making other ways of understanding problems and to provide solutions. we can find frozen water all around different areas in this planet, especially in the north and in polar regions, of course. But we also can find indigenous peoples there and local communities as well living. And Julia, you just asked how this glacier melting and shrinking of the permafrost will affect you and other people. But imagine how these complex events will affect people living specifically in those places. So it is very important to consider other understandings of the planet and the Earth processes. And when I'm talking about this, and all the time when I'm giving a talk about indigenous knowledge or indigenous science, everyone, I don't know, start thinking about esotericism, about indigenous peoples are so wise and they take about Mother Nature, which is true and it is very important. But it's important also to consider that local and indigenous knowledge spans from different scales and levels, from the local to the global. So we have precise and accurate understanding with methods and approaches and our own indigenous tools and how to take measurements of the local conditions. And this apparently now is attracting attention to these UN forums or those organizations that they really want to make sense of local or in situ observations to bring this information, this data, into the global monitoring of water processes or earth processes in general. So it makes sense also to include other ways of thinking. And how to do this is a challenge, of course. Actually, yesterday I had a really wonderful conversation with someone that was asking me that particular question, how we can bring this in knowledge of the people living there. And it is important to first to think that there are methods, tools, and approaches to do that comes not from Western science, but from indigenous epistemologies and ontologies. So there is a way of naming the ice in different regions. There is a way to predict where the snow is going to arrive in a particular day, and it's very precise and accurate. And I think satellites and this global information data is crucial, but we are really going in a line that is not very good for humanity in general. We are crossing different planetary boundaries. And we are talking here that we have scientists traveling to those places to understand what is happening, but why not to work alongside the people living there and respect their ways of thinking and their ways of understanding those natural processes. We are talking about the EI, intelligence, and why we are using other intelligence that we have intelligence in that particular places. And the main message I want to bring for you and for the audience is that it's important to consider indigenous peoples as allies for understanding Earth processes, because indigenous peoples, they were the first Earth observers of the planet. So they were very good in determining astronomical events that they are not happening, they need to happen in the future. So we need to really include this a different perspective into the decision making. And I can give examples, but I'm sure we will continue with the discussion.
Yeah, thank you very much. Thank you for giving us another dimension. Now we can see how is dimensional the problem of glacier. From one side we have science, we have data, we have models. From another side we have local people who rely on the melting glacier, who are using this water and rely fully on agriculture and food production from those glaciers. And we also should consider we have diversity of tools to collect the data, and this is our benefit, it's our perspective to use this data properly. Please let me to turn to another part of our discussion. What we can do now, because we always tell about the problem, it exists, we have negative, positive impacts, we can predict, but what we can do, how we can mitigate, but also probably because it's water, how we can adapt to this change. And let me to back to Antarctica question a little bit. To back to this remote area and to ask Irina again. So, what actually we can do to stop all these problems? So how we can adapt or mitigate to these problems what now we are facing with melting of Antarctica? What can be the solution? I know that it doesn't exist exact some recipe, but what can be our participation in that?
It's a difficult question with a very simple answer. We have to decrease our emissions. We have to go net zero. We have to achieve the 1.5 degree global warming. And regarding to Antarctic impacts around the globe, which are already huge now, so they are impacting population, ecosystems around the biodiversity around the globe. So we are talking about the impacts on, speaking about people, there are 600 million people living in the coastal areas. So this is global sea level rise caused by the melt of Antarctica. It's already have this impact, and it will continue stronger in the future with coastal flooding, with tidal effects, with shoreline erosion, with saltwater contamination of freshwater aquifers and streamlines. So these things will become even stronger in the future. And the message from the Cryosphere community is actually very simple, that it's, and we have to keep this, the Paris Agreement, we have to keep this as the goal, like 1.5 degree and not more. And actually, with respect to Antarctica, it cannot even stay long at the 1.5 degrees, because passing this threshold, it will trigger a lot of tipping points in Antarctica. So we're in the danger that big parts of West Antarctica will start the disintegration. It's already disintegrating. It's already started. But it will be faster and faster, and there will be this really huge amounts of ice being lost from West Antarctica, and then East Antarctica will start destabilize as well. So we can, if we can still adapt to the changes now, to the changes that happen in the cryosphere and the changes within the cryosphere and globally that are caused by the cryosphere, we can still adapt to them if we keep the global warming below 1.5 degrees. But if you go beyond this, if you go to 2 degrees, if you go beyond the 2 degrees, that can cause more than 3-meter global sea level rise. We can even go to 12 to 20 meters by 2300, which is huge, right? This is already not a pink. This is huge amounts, really. So, and what our actions now, basically, they will determine the future multiple generations. Because the way Antarctica responds to global warming, it's like a slow giant, like it's really moving really slowly. But then when it steps on you, it crushes you. It's like, and it can also fall down, like, and then it will have really catastrophic impact. So the 3-meter global sea level rise, it can wipe out the entire low-lying nations and the shorelines. So this is what we are facing now by the end of this century, and we are talking about, again, the generations of children. I have 2 young daughters, and they are facing this. They will be facing this when they are adults. So they're like, and when we speak about again, the Antarctic response, it's these tipping points which are really dangerous, because we are starting to understand them now, using observations, using high-resolution models, using more understanding of physics and chemistry and biology happening there. So we have gained a lot of knowledge. Now we can say for sure that the message is clear, that the melting point is not listening to any negotiations. It's simple physics. When it's too warm, it's melting. And what we can do now, our actions now, they will be felt in the several generations of the future. So.
Thank you very much. Thank you for mentioning about future generation. Recently we had snow in Vienna, and I just recognized what my son, he's 8 years old, but it's only second time he was able to ice skate in his life. Before we did it very regularly, so now even we are losing this type of activities. Thank you for mentioning this important aspect. And I would like to ask Adrian, we have also another very important IPCC panel that is working on that. what aspects need attention in the new cycle of this intergovernmental panel on climate change, we know is APCC, and how we can involve broader community scientific, because we know scientists mostly work in one specific field and very rarely go to the broader. How we can involve more scientific groups to this problem would help us to mitigate and probably adapt to this change.
Yeah, thank you so much. Excellent question. And just for your son, don't come to Denmark then, because we measured that we, as a very cold Nordic country, we have 3 weeks less of winter now compared to before we started emit greenhouse gases. So that's quite a lot less snow, unfortunately. So I think that many of the points just raised here are very, very important in terms of where should the scientific agenda go. So I'll talk a bit about a few other things. I think one big issue, of course, is understanding better how the cryosphere is changing. So that's the physical part we just heard about. What we need to do in particular, I think, is to bridge that insight to the local impacts that we are experiencing around the world. And I appreciate very much the point about indigenous people's experiences and local communities' experiences. And I think it's that bridge that really could benefit to be more integrated. So, for instance, when physical scientists are doing their models, that's good. What we need to do is to bridge that to other disciplines and to the local communities in terms of how the impacts are working on a local scale. Just to take one example, I think there are many communities around the world that at the moment are experiencing an increase of freshwater resources. That's very good. But the problem is, of course, that that increase is not lasting for very long. So it's about to peak, and how does that change both the culture, the ability to live in different communities, and how, I think we also had a comment about that earlier, how can communities adapt to those changes? So that's really how we need to integrate the different types of disciplines that have, well, it is starting, but it's not enough integrated. Another thing that is really important, I think, is for the scientific community to be directed towards the needs of local communities. So, for instance, when we at the Danish Meteorological Institute and my climate center, when we use our efforts to understand changes in the Arctic region, we also try to involve local communities to understand where should we put our efforts into. So, for instance, what I mentioned before about the sea ice and the ability to move on the sea ice as local communities, that's really one of the key issues for Inuit and local communities to understand better. So that's the coupling that we want to do. And then more broadly, I do appreciate that we need other types of information, but I really think that in order to evolve, especially on the model side, we do need machine learning and artificial intelligence. It's not everything, but it's one very important tool, because we are working in very inaccessible areas. Greenland is huge, not compared to Antarctica, but it's quite big, and we don't have enough measurements. So using satellite data, the measurements that we have on ground, and using machine learning tools to integrate into our models to get a larger variety of and understanding risk and uncertainties in the models is a key area that we need to work more on, I think.
It's my lovely subject, artificial intelligence, and we are using it very often now for isotopes, because isotopes, compared to measurements like meteorological, hydrological, they integrate more information. So they can be very useful to predict diversity of change in one measurement. So thank you. Yes, we are also developing, and we are going further and further. It will be nice to cooperate also in this subject all together, because the data is growing, the amount of the data is growing. But sometimes we have also lack of data. This is also helpful. And artificial intelligence, but also we can fill it with maybe local information. Let me go back to the local information, because it's also very important to fill also this gap, but also to integrate the diversity of different groups, social groups who participate in this problem, who can help us to mitigate and to adapt to this change. Yolanda, how can hydrologists and experts bring local community knowledge? What can help us to improve models? What can help us to participate in mitigation and adaptation to this change that we experience now?
Yeah, thank you, Julia, again. Well, of course, this is not an easy task, and it requires a lot of work. But the first thing is to really recognize the value of indigenous science. It's not about personal experience, it's science, is precise, and it's accurate. And the other is why we don't use this, because we don't have it published on journals and papers. I'm also a scientist, and I know how the academic system functions. So we publish a paper, we get publications, and we cite each other, and the information is circulating within ourselves. And just a few papers really influence policy and practice. Why we don't have in those journals and academic papers indigenous science, indigenous information, because unfortunately, indigenous peoples, we have been experiencing a loss of our own knowledge due to the different historical processes. But the first step is to recognize that it's valid and it's accurate and precise information. And the next step could be, for example, to really include in situ observations of the people into the models. And you probably may ask how I will do that. But it's important to work alongside, for example, the hydrologists, but to use the knowledge of the people to get your estimations for your models, first at local level, and then to probably expand with other technologies and other tools in order to have this global perspective. Also, the people, indigenous knowledge is locally based, but also it is different among different groups. So it's not, for example, I'm Maya, and the Mayas were a water-oriented society. They were very good in estimating changes on the water cycle. They were very good engineers. They modified the landscape according to their needs. And the hydrological cycle within my region is totally different to the hydrological cycle people like the Sami or the Inuit or the Anishinaabe, they experience in their own places. So it's, the knowledge they have is about the water cycle, but it's locally based. So they really adapt their conditions to survive in different places. So you will have different information depending on the site you are doing your studies or modeling or doing whatever is needed in order to understand Earth processes. And another step could be, for example, to really invite indigenous scholars, which, like myself, and I have other colleagues in attending this event, in which we know how to speak the scientific language, but we can bring our indigenous understanding of the processes of our planet. So we can start by doing small little steps until we reach all together as humanity a point in which we all can thrive.
Thank you very much. It reminds me one proverb what we told a long time ago: act locally but think globally. And very often now with these global models, we are losing this local part. So we are trying to, also artificial intelligence is nice too, but we try to generalize everything and not to look with specific things what we have, with diversity what we have on our planet. Thank you very much. And I'm sorry, Johannes, I'm keeping you on pause for some time and would like to ask you the last question in our panel. How, from the UN perspective, what some measurements can be implemented to adapt to this challenge what we now discussed, and how we can ensure sustainable water management under these conditions?
Okay, that's the million-dollar question. I think a lot of data is there. So we always talk about that we need more and better data. I think we have a lot. I think what we need to, I don't say we need to stop measuring. So I come from an organization where we always advocate for more measurements and also more ground-based measurements and more local measurements, because if you want to understand the hydrological cycle that I have worked, for my master thesis in the Amazon. And when I went there, I thought, okay, I'm going to do some piezometers and seepage meters here. And then with a couple measurements, I know how much water infiltrates or exfiltrates from the lakes in the Amazon. But actually, the infiltration rate varied like 2,000% over a few tens, like decameters. You cannot, the subgrid or sub-scale variability in our process is always so high that if you just come with a satellite alone, it won't work. So, but what I want to say is we need to be aware of the different scales and the different types of data and information that we need. And then most importantly, we need to stick that together, because it doesn't help if the cryosphere scientist does isotope studies in Greenland ice, but the hydrologist doesn't understand what it means for the hydrological cycle in their water management oriented modeling. And artificial intelligence is a good tool that we can use, but it's an interpolator. It's not an extrapolator. So we cannot predict something that hasn't been known or observed, or that doesn't work. So that's just not possible. So we can use all those new technologies to understand better and to give people a better foundation for management. And then I think it comes to this dichotomy between policy making or top-down management and what actually the people need to know and also want to do. So, and I mean, we are now in Dubai, and yeah, when we stand under the shower here, the perception is different than we stand under the shower in Denmark, maybe. So I think that that dimension is also linked to it. So water management, I think, must be supported by the most adequate information. And I will do 1 minute in terms of explaining how that works. I mean, we are human beings, we work on heuristics. We can't even catch a ping pong ball or a tennis ball without our brain playing a trick, because our system is not able to catch a ball when we process how the ball comes to us, and we have to move the hand to catch it. So the brain does a trick with us, and we just look at the angle that the ball is coming in, and then we can catch this ball. So we don't understand the whole process, but we make a decision that leads us to be able to catch the ball, or the apple that falls from the tree, or what. So the brain is under these heuristics all the time, and if we don't understand that we use different ways to take decisions. I'll finish. Okay. Then I think we are missing the point. We're trying to explain stuff to people that they cannot apply. So I think that is a wrong assumption that scientists very often have. We don't understand how people take a decision. I came to that as a flood forecaster. I thought, why are the people not taking away their cars? Because it has always went okay in the past. That's a heuristic mechanism. And so to take right decisions, we need to understand the levels of willingness of people to engage on a certain type of information. That, I think, that is for me the key thing. Isotopes are a nice thing to use in that regard, because you can very easily explain to people how much water is where and when, and this knowledge about how water is moving on the earth in the solid or in the liquid phase or in the gas phase, I think is what must underlie the information of people to take a decision that is a little less heuristic and a bit more aware. And yeah, if we can do that, I think that would be beautiful. Thanks.
Yeah, thank you. Yeah, when I take a shower in Austria, actually, I thinking what is glacier melting. That is my shower became very short now. So, maybe we have for one comment, because someone would like to, before Martin will give us closing remarks, Svetlana, please, you'd like to ask question or comment?
Okay, well, 20 seconds. Thank you for mentioning me, because we really were in Vernadsky we made these measurements for 60 years, and I just want first to say that we want publication actually in our journal. We have our Ukrainian Antarctic journal, so maybe for isotopes it's one comment. And one question you said about generation, and we speak about scientists. So what kind of programs you have maybe in UN water to train new generation? Maybe it's long actually question, but in fact I guess it's what we need to think about, the next generation of scientists in fact, who will continue our measurements and who will actually make it not only as artificial intelligence, but with our brain intelligent. So.
Well, I can start at least from the perspective of Denmark and Greenland. I mean, what we're trying to do, and I really appreciate your point about people are not, and I'm people as well. I'm not able to understand the science that we produce because my brain doesn't really, I can't comprehend it. So what we need to do, I think, is really to bridge the science that we do into a service and a very clear and communicative point. So in Denmark, for instance, what we have done is we've made a climate atlas. So we take the global IPCC models, we downscale it to a regional level at a European scale, and then we downscale it to a very local level at a local community scale. So what are the sea level rise changes in 10, 50, 100 years from Antarctica, from Greenland, and from the ocean warming at the place that you live in Denmark. And we're trying to do that in Greenland as well. And we reproduce it in a graphical way that is very, very easy to understand and easy to explain and easy to talk about. And I think that's something we need to do across all the different disciplines that we do. And even when we have done this, it's still difficult to take up that knowledge and use it. But I think that we need to continue the dialogue about it. So more dialogue is really the key tool, I think, to give an insight to new generations as well.
Thank you very much.
Very short comment. I think it's important to train not only scientists, but also to make all the people aware that each human has to have a certain amount of water literacy, which I define as a minimum understanding of the natural processes of the water cycle in this case, in order to be able to understand the complexities and to develop within ourselves the needs for taking care of the planet.
Thank you very much. So I would like to invite Martin. Thank you, dear panelists. I would like to close the event with the remarks from Martin. Martin.
Thank you, Julia, and thank you very much to our panel here. What we heard this morning really helped to unpack the complexity that you have described. You know, if we look at the Earth's processes, the interaction between biosphere, atmosphere, cryosphere, hydrosphere, it's mind-boggling. When I was a student of geography many years ago, one of the subjects that we had to study was glaciers. And for us at the time, and I'm talking about 30-something years ago, glaciers, that was a very remote topic, a corner topic, something of the remote past. It was not something in focus or relevant to our lives. Now, what we have heard this morning really, I think, has made the case that the cryosphere and glaciers are something that deserves attention and focus. What we have not really discussed this morning is the interaction or the connection or the teleconnection, as somebody has said, between the Earth's processes and the economic and social processes or the impacts on people, on our economy. We have touched upon it a little bit, at Yolanda, but that actually deserves another panel, and maybe we should organize another panel to look at what actually are the impacts of sea level rise, of runoffs from mountain rivers, causing havoc sometimes downstream in the valleys. What are the impacts of those natural processes on our social and economic fabric? So I'm working at the International Atomic Energy Agency. I'm a director there, and we are working very closely, of course, with our Department of Nuclear Applications. But what we do is, in our department, we have a number of projects where we are trying to build capacity of local scientists to deal with isotopic science, to build capacity in the laboratories to use isotopic science and other nuclear techniques and applications such as the cosmic ray sensor technique, to build capacity in our member states to have a precise picture, to come up with data, to have precise science that underpins any policy action, anything that you have been talking about that needs to be done. Let me close maybe by, I guess, Julia, you will thank the panel also, but I really enjoyed this session. I think somebody, Irina, I think you said, when you were asked about what is the solution, let's look forward. We are good in analyzing our problems here, but what is the solution? Net zero is obviously the solution that we need to embrace. And, I would close by saying investing in glaciers by accelerating the path to net zero is maybe the solution that we need to promote. Thank you.
Thank you, Martin. We're a little bit running off the time, but it shows us how this subject is important. That is why we cannot stop. Still a lot of aspects that we can discuss, and probably next time we should make this event longer, at least on half an hour. So at the end, I would like to thank all panelists. It was really amazing to share all this experience. We have the diversity of the discussions. And we understand now we should continue to look at this subject from different perspectives, from economic, from cultural, from scientific, from artificial intelligence also. So everything is important here. So thank you once again, and thank you for joining us today, all audience and also audience online. And thank you. So we are